Okay, for this lesson, we're going to take a look at the first algebraic method for how we can solve a system of equations. So we're going to look at how to do it using substitution. So we already looked at how to do it graphically. We can graph out both the points using our slope y-intercept form or our slope point forms, and then find the coordinates for where they cross. Now, if we're doing it through substitution, we're going to choose one of the equations, typically the simpler equation, because more often than not there's going to be one equation or the other that's going to be easier to isolate a variable. We're going to isolate the variable in that equation, and we're going to substitute the entire expression for what that variable equals into the variable spot in the other equation, making sure that we use brackets. Then we're left with just one equation with one variable in it. We can solve for that variable using that one equation, and then take the solution from that equation and substitute the value of that variable back into the first equation in order to solve for the second variable. So let's take a look at how this works. First, considering the following systems, I have x plus 4y is equal to 17 and 2x minus y is equal to 7. Well, I'm going to label this as equation 1. I'm going to label this as equation 2. The first thing we're going to do is we're going to solve the system using the method of substitution by rewriting the first equation in the form of x equals. So I'm going to take equation 1 and I'm going to get x by itself. And I'm going to say that x equals, well, when I move the y to the other side, negative 4y plus 17. And this is all from equation 1. Now I'm going to take what x is equal to in equation 1 and replace x in equation 2 with that. So I'm going to go to equation 2 and say that I have 2, use brackets to substitute, negative 4y plus 17 minus y is equal to 7. And now I have that equation with just one variable. Now I just have the y's. I'm going to multiply this out and say that I have negative 8y plus 34 minus y is equal to 7. I can combine my y's and so that I have negative 9y, and I'm going to subtract 34 from both sides and say that I have negative 27, and then I divide both sides by negative 9, y is equal to 3. Now, because I did this with the second equation, I'm going to take this and put it back into the first equation and say that in the first equation, if x is equal to negative 4y plus 17, it's going to be negative 4 times 3 plus 17. Or x is going to equal negative 12 plus 17, and x is equal to 5. And now I have my set of coordinates. The solution is going to be at 5 and 3. I could have done the same thing by starting by substituting into the first equation and isolating y. So if I want to do that, well, actually what I'm going to do is I'm going to isolate y in equation 2. So I'm going to take equation 2 and say that if I have 2x minus y is equal to 7, then negative y is going to equal negative 2x plus 7, or y is going to equal 2x minus 7. I'm going to pull that from equation 2 and put that into equation 1. For equation 1, I'm going to say that if I have x plus 4y, well, it's going to be 4 times 2x minus 7 is equal to 17. X plus 8x minus 28 is equal to 17. Or 9x, and I add 28 to both sides, is equal to 45. X is equal to 5. because I did that in equation 1, I'm going to take that solution and substitute it back into equation 2. Y is equal to 2x minus 7, so 2 times 5 minus 7. Y is going to equal 10 minus 7. Y is equal to 3. And I get the same result. My solution is still 5 and 3. Now, here's the important part. We could have messed up when we were rearranging the equations, just like what could happen when we're doing it graphically. So we always need to verify for both equations that this set of coordinates works. We always verify it with the equations in their original form. So I'm going to start by verifying for equation 1 and say that if I have 5 for x plus 4 times 3 for y is equal to 17, then 5 plus 12 equals 17, and 17 is equal to 17, and that one works. Now I'm going to check it with equation 2. 2 times 5 minus 3 is equal to 7. 10 minus 3 is equal to 7. 7 is equal to 7, and that works. I can also use my graphing to verify this. I'm going to isolate and put the y equals into my calculator and check and see if it works, and in this case, it does.